Hey everyone, welcome to this explainer. Okay, let's start with a fact that completely, and I mean entirely, shifts how we see our world. We always call Earth the blue planet, right? We see those massive, beautiful oceans from space. But get this, out of all the water on Earth, only 1% is accessible surface fresh water. Yeah, just 1%. It is a huge reality check. We are literally entirely dependent on this incredibly tiny sliver of water to sustain all human life, agriculture, industry, the whole shebang.
To put that 1% into perspective, think about it like this. 97% of our water is locked up in the oceans. It's salt water. So out of the 3% that's actually freshwater, almost all of it is trapped in ice caps, glaciers, or buried way deep underground. That leaves us with just this tiny 1% slice at the bottom. Our lakes, our rivers, our soil moisture. Seeing the data laid out like this really drives home the staggeringly high stakes of global water scarcity. I mean, every single drop of that 1% is absolutely critical.
So what do we do about it? Well, today we're going to dive into a fascinating structured look at how we can actually solve this global water crisis. We're going to be exploring a framework developed by Dr. Hernan Ruiz Ocampo. It maps out a complete paradigm shift, moving us away from an outdated, highly wasteful system and toward a continuous, life-sustaining loop that we call circular water management. Here's a quick roadmap for this explainer so you know exactly where we're headed. We'll kick things off with the global water crisis, then look at the linear water trap that's really holding us back. From there, we'll dive into the circular water solution, how we're rethinking water infrastructure, the technologies driving the change, and finally, how we're transforming waste into resource. Let's get right into it. Section 1. The global water crisis. We all know climate change and human activity are accelerating disasters like floods and droughts. But you know, the quiet, terrifying crisis is actually in the numbers. Globally right now, a massive 80% of wastewater is just not collected or treated properly. 80%. On top of that, forecasts are showing that nearly 70% of the world's population will soon live in urban areas. That is going to put unimaginable pressure on local water systems. Look, if we don't change course, global water demand is projected to overshoot our supply by 40% by the year 2030. 2030! That's right around the corner. Our current trajectory is literally unsustainable. Section 2, the linear water trap. Now, this outdated model we're using, it's pretty much the villain of our story here. It operates on a very simple, very flawed four-step pipeline. Take, make, lose, and discharge. We take the water from rivers or aquifers, we make it drinkable, we use it in our homes, our farms, our factories, and then we just discharge it right back into the environment, and usually as polluted wastewater. We're treating a finite, life-giving resource like it's just disposable garbage. You can clearly see how this linear economy flows, from the freshwater source on the left, running through the treatment plants out to domestic and agricultural use, and then straight out the discharge pipes on the right. The water is extracted, it's used exactly once, and then it's dumped. Boom, done. And honestly, that is the root of the entire problem. Section 3, the circular water solution. Okay, so to fix this mess, we need a massive, total paradigm shift. We have to start treating water as a continuous, renewable cycle. And this is made possible by what we call the 7 Rs. First, we need to reduce water usage right at the source. Then, ensure the removal of hazardous pollutants. We need the reuse of wastewater for things that don't require drinking level water, and the recycling of water for when we actually do need potable use. We also absolutely have to focus on the recovery of valuable resources, like minerals and energy from that wastewater. We must replenish our natural systems. And honestly, transversely, we just need to rethink how we use resources entirely. Look at how elegantly all these pieces fit together. Those 7 Rs feed directly into the central circular economy water framework. But they don't work alone. Surrounding them, you've got digital technologies like IoT sensors and smart management, optimizing the whole thing. And holding up the foundation, circular business models. Because, let's be real, creating value from recovered resources actually has to make economic sense for utilities to do it. It's an entirely integrated, incredibly smart system. Section 4, rethinking water infrastructure. Having a beautiful framework on paper is great, but, you know, we actually have to physically build it. And here's the catch. Our existing infrastructure was absolutely not designed with circularity in mind. In fact, most of our major dams, our massive sewer networks, and big water management systems, they were built way back between the 1930s and the 1970s. This aging infrastructure was built exclusively for that wasteful take, make, discharge linear model. Adapting these old, rigid systems to handle modern resource recovery and water use is an incredibly urgent challenge. Because of these aging setups, we really can't just rely on massive, centralized mega plants anymore. Moving from those heavily centralized systems to decentralized, or at least hybrid, networks is a total game changer. Think about it. By treating wastewater right near where it's generated, like in a specific neighborhood or an industrial park, we drastically cut down on piping and pumping costs. It makes local reuse and local resource recovery so much more feasible and efficient.
Section 5. Technologies driving the change.
So to make this circular economy an actual reality, we need some serious high-tech tools to clean the water and pull out the hidden value. Let's look at 2 standard biological treatments used to break down organic waste. Historically, we've heavily relied on aerobic digestion. This means continuously pumping huge amounts of oxygen into the water so bacteria can eat the waste. As you can guess, it is incredibly energy intensive. But then we have anaerobic digestion. This happens completely without oxygen. So not only does it use way less energy, but the bacteria actually produce methane biogas as a byproduct of breaking down the waste. You're basically turning a treatment process into a miniature power plant. How cool is that? You can really spot the difference when you look at these systems side by side. The aerobic process requires this constant, massive input of air. But over in the anaerobic system, specifically the USB reactor, look at what's happening. We are actively capturing biogas. So instead of just sucking up power from the grid, the treatment plant is actively generating alternative energy for heating and electricity. It's brilliant. Now, when it comes to the water itself, we need strictly tailored quality control based on the exact size of the pollutants. It's like a giant sorting puzzle. Microfiltration is great for catching the big stuff, like algae and bacteria. But if you want to stop dissolved salts and the absolute smallest viruses, we have to push all the way down to nanofiltration and reverse osmosis. The point is, we have the guardians in place to perfectly tailor the technology to get the exact quality of water we need to reclaim. Section 6. From waste to resource. This is where the circular economy truly shines. It's about transforming what we used to call wastewater treatment plants into futuristic resource recovery facilities. What we historically labeled as pollution is really just misplaced wealth. For example, recovered nitrogen and phosphorus, that becomes premium agricultural fertilizer. Organics become biogas and thermal energy. But wait, it gets even better. Think about desalination plants. They traditionally produce this highly toxic hypersaline brine that gets dumped and threatens marine life. But now, through groundbreaking initiatives like the Sea for Value project, we are actually mining that ocean brine. We are extracting critical raw materials, things like lithium, magnesium, and gallium. We are literally turning a severe environmental threat into a secure, local source of critical tech materials. It is a massive win-win. And for the water itself, by mixing and matching those advanced filtration technologies we just talked about, like ultrafiltration and reverse osmosis, followed by some heavy-duty disinfection, we can dial in specific, perfectly safe grades of reclaimed water. Whether a community needs it for watering crops, running massive industrial cooling towers, or even safely replenishing drinking water aquifers, we have the exact tech to make every single drop count, multiple times over. I want to read this quote directly from our source material because it really hits the nail on the head. It is the absolute core ethos of this entire paradigm shift. Water utilities must transition from treatment plants to resource recovery facilities to include circular economy principles while ensuring high-quality treatment. See, it's no longer just about cleaning up a mess, it's about actively mining our wastewater for the immense, undeniable value it holds. So, I'm going to leave you with this final, provocative thought. The next time you turn on your tap, watch the water swirl down the drain, or look out at the vast ocean, ask yourself, what valuable resources are we just washing away? Energy, fertilizers, or even the very lithium that's powering the smartphone in your pocket right now. It is all right there, just waiting for us to close the loop. Thank you so much for joining me for this explainer. Keep learning and keep rethinking our world.